Okay, so here we're going to look at a graphical representation of Charles' law, right? We'll look at a graphical representation of Charles' law. So, like I said before, Charles' law states that the volume of a fixed mass of gas is directly proportional to the absolute temperature in Kelvin, right? Provided the pressure remains constant. So, this is a mathematical representation of Charles' law, that the volume of a given mass of gas is directly proportional to the absolute temperature, which is in Kelvin, provided the pressure remains constant. Right? So these two graphs are graphs that describes Charles' law. So when you see a graph in your exam and you see that the vertical axis has volume and the horizontal axis is temperature, that graph is most likely going to be a what? A Charles' law graph. So if you look at this graph, on the vertical axis, we have volume. And on the horizontal axis, in this graph, we have temperature in degrees Celsius. So if you look at this graph very well, this line, this line, it cuts across the origin of the graph. It cuts across this point. This is the origin of the graph, right? This is 0 degrees Celsius. So it cuts across the origin of the graph down to minus 273 degrees Celsius, right? And this temperature is equivalent to 0 Kelvin, right? So this temperature is what is called the absolute zero. Absolute zero. So at this temperature of minus 273 degrees Celsius, or this temperature which is equivalent to 0 Kelvin, this is the temperature at which the volume of the gas becomes theoretically zero. So at this temperature of minus 273 degrees Celsius or 0 Kelvin, the volume of the gas will be equal to what? Zero, right? This is the temperature at which the volume of the gas becomes zero. And that is why you don't use degrees Celsius in gas law, because the graph does not pass through the origin of the graph. It does not pass through the origin. And this is the origin, right? That is why you don't use degrees Celsius, because it cuts across down to minus what? 273 degrees Celsius. And this temperature is known as what? The absolute zero. It is equivalent to 0 Kelvin. So this is volume against temperature in degrees Celsius. That's when you have this kind of graph. Then when the graph is like this, when the graph comes or passes through this origin, right? This is the origin of the graph. There is where we have 0 Kelvin, right? So this is the origin of the graph. Here we have volume and here we have temperature. So when the graph passes through this origin or comes from this origin, right? We use Kelvin. We use Kelvin in terms of temperature. So these two graphs are graphs that represent Charles' law, and you should be able to differentiate the two graphs, right? This is in degrees Celsius, this is in Kelvin, right? So again, Charles' law states that the volume of a fixed mass of gas is directly proportional to the absolute temperature in Kelvin, provided the pressure remains constant. So this is Charles' law, and these two graphs are graphs that represent Charles' law.